Let us evaluate this integral from 0 to infinity 1 by 1 plus e power x dx using three different methods. First method, that is, consider I is equal to integral from 0 to infinity, it is 1 by 1 plus e power x dx. In method 1, it's a simple method and we shall multiply this denominator and numerator by e power minus x. This is e power minus x, such that this e power minus x cancels with each other and the integral remains as it is. That is, I is equal to integral from 0 to infinity. This is 1 into e power minus x is e power minus x divided by, and in the denominator we have e power minus x into 1 is e power minus x plus e power x into e power minus x is 1 dx. Let us take a substitution for this. 1 plus e to the power of minus x equal to t. For x equal to 0 we have t is equal to 2. 1 plus e power 0 is 1 and 1 plus 1 is 2. And for x equal to infinity we have t equal to 1. 1 plus e power minus infinity, this is 0 and t equal to 1, and e power minus x dx equal to minus dt. This is the required substitution we need, and the integral is changed as I is equal to integral this. For 0 we have x equal to 0 plus t equal to 2, and for x equal to infinity we have it as 1, and e power minus x dx is minus dt minus outside by 1 plus e power minus x is t. Here we have completed until I is equal to integral minus from 2 to 1 dt by t. This is, we know integral dx by x is equal to log x. Similarly we have I is equal to minus, this is dt by t is nothing but log t from 2 to 1. That is, I is equal to minus, within the brackets we have upper limit minus lower limit, log of 1 minus log of 2. We know log 1 equal to 0, and I is equal to minus of 0 minus log 2. That is, I is nothing but integral from 0 to infinity 1 by 1 plus e power x dx equal to minus into minus is plus, and this is log 2. This completes the first method. Let's find the second method 2. To find integral from 0 to infinity 1 by 1 plus e power x dx. Let this is equal to I, and let substitute e power x equal to tan square theta. We have e power x dx equal to 2 tan theta into derivative of tan theta is secant square theta d theta, and we have dx equal to 2 tan theta by 2 tan theta secant square theta by tan square theta d theta. That is, dx equal to 2 secant square theta by tan theta d theta. And we have, for x equal to 0 implies theta equal to tan theta equal to 1, theta equal to pi by 4, and for x equal to infinity we have theta equal to pi by 2. This is the required substitution for us, and the above integral is reduced. I is equal to integral from, for 0 we have it as pi by 4, and for infinity we have it as pi by 2. Dx is 2 secant square theta by tan theta, 2 secant square theta by tan theta, and similarly in denominator 1 plus e power x is nothing but tan square theta into d theta. Similarly we have I is equal to integral from pi by 4 to pi by 2. This is 2 secant square theta, and we know 1 plus tan square theta is secant square theta. This secant square theta gets cancels with each other. Then the remaining term is 2 by tan theta. 2 by tan theta into d theta. That is I is equal to twice integral from pi by 4 to pi by 2. We have 1 by tan theta as cot theta d theta. Cot theta d theta, and we know I is equal to twice. This is integral cot theta is log sin theta. Log sin theta from pi by 4 to pi by 2. That is I is equal to twice log sin pi by 2 minus log sin pi by 4. I is equal to twice, this is sin pi by 2 is sin 90 is 1 minus log 1 by root 2. We have I is equal to twice log 1 is 0 minus, this is log 2 power minus 1 by 2. That is I is equal to twice, this is minus into minus 1 by 2 into log 2. This 2 gets cancelled, minus into minus is plus, and we know I is nothing but integral from 0 to infinity 1 plus e power x dx equal to minus into log 2 by method 2. This is log 2. Now by method 3. Thus find the same integral by method 3. I is equal to integral from 0 to infinity 1 by 1 plus e power x dx. For this let us make 1 plus e power x equal to t, and we have e power x dx equal to dt. Dx equal to dt by e power x, and e power x equal to t minus 1. And we have for x equal to 0 we have t equal to 2, and for x equal to infinity we have t equal to 1 plus e power x dx, and for x equal to infinity we have t equal to infinity. The above integral is reduced as I is equal to integral from 2 to infinity dx is nothing but 1 by e power x means t minus 1 into t dt. By partial fractions 1 by t into t minus 1 equal to, this is t minus 1, this is t. If you close this term and put t solution as t equal to 0, we have 1 by 0 minus 1, that is minus 1. If you close this term, the solution of this t equal to 1, and if you put 1, we get this is a partial fraction of this. I is equal to, here we have integral from 2 to infinity. Instead of this term, we can write this as 1 by t minus 1 by t minus 1 dt. This is I is equal to integral 1 by t is log t minus, that is log of t minus 1. Consider mod. We have this limit from 2 to infinity. This is log a minus log b, that is log a by b, t by t minus 1, 2 to infinity. And reducing these partial fractions, we have it as minus 1 into minus of, and here we get minus, this is minus, here we have minus, then I is equal to, and putting that minus to the power, we have log t minus 1 by t from 2 to infinity, that is I is equal to log of 1 minus 1 by t from 2 to infinity. I is equal to log of, on substituting the first limit, we have 1 minus 1 by infinity minus log of 1 minus 1 by 2. This is I is equal to log 1 minus log 1 by 2. I is equal to log 2. It is integral from 0 to infinity 1 by 1 plus e power x dx equal to log 2 by method 3. We have 3 methods to solve this solution. Thank you.